Some walls were designed to fail and then recover. That idea is older than modern concrete. At first, this sounds impossible. We live in a world full of advanced machines, engineered materials, and modern science. Yet cracks in buildings are everywhere around us. Houses crack, walls split, concrete breaks. We see it so often that we accept it as normal. We assume cracking is just part of how buildings age. But across Europe, there are walls that cracked hundreds of years ago and then slowly closed those cracks on their own. No workers came back to repair them, no modern tools were used, no written records describe major fixes. The wall simply recovered over time. This is not a legend or a romantic story about the past. These walls still exist, and their behavior can be measured and tested today. For a long time, even historians struggled to explain this. Many believed these walls survived because they were thick, or because people maintained them better. Others said it was luck, but those explanations fall apart when the same pattern appears again and again in different places, built by different people across different centuries. Something else was happening inside these walls. If you enjoy learning how old ideas quietly outperform modern ones, you might want to stay with this channel. We explore forgotten designs like this every second day, not as myths, but as real systems that still work. Modern concrete looks powerful. It feels solid and permanent. When you touch it, it gives the impression of strength. But strength and durability are not the same thing. Modern concrete is built to be hard and fast. Medieval walls were built to last. That difference changes everything. When modern concrete cracks, the damage rarely stops. The crack stays open and slowly grows. Water enters through it. Steel inside begins to rust. Over time, the structure weakens even more. This is not a failure of construction skill. It is the result of how modern concrete is designed to behave. Modern concrete is engineered to set quickly. It is poured, hardened, and stressed within days. That speed makes modern construction possible at large scale. Buildings go up fast. Projects finish on time. But that speed comes with a trade-off. Once modern concrete hardens, it becomes rigid. It does not like movement. It does not adjust well to temperature changes. It does not respond kindly to moisture. The world, however, is never still. The ground moves slightly. Temperatures rise and fall. Materials expand and contract. When modern concrete is forced to deal with these changes, it has only one response. It cracks. Medieval builders faced the same forces. Their buildings experienced heat, cold, rain, and ground movement, just like ours do today. But instead of trying to resist all movement, they planned for it. They did not see flexibility as weakness. They saw it as survival. Medieval walls were not simple solid blocks. They were systems made of stone, mortar, and space working together. The stones provided strength, but the mortar between them played a much deeper role. That mortar was not meant to freeze in time. It was meant to keep changing slowly. This idea feels uncomfortable to modern thinking. Today we expect materials to be finished forever once they harden. In the medieval world, materials were allowed to continue reacting with their environment. That difference is critical. Medieval builders used lime-based mortar instead of modern cement. Lime behaves very differently. Long after a wall was completed, the mortar inside it continued to interact with air and moisture. When small cracks formed, water entered the wall, but instead of only causing damage, that water often triggered a slow repair process. This is not poetry or imagination, it is chemistry. Lime can slowly turn back into stone-like material over time. That process can seal tiny cracks and strengthen weak points from the inside. The wall does not heal overnight, but over years and decades, it quietly corrects small failures. For centuries, no one paid attention to this. Old buildings were assumed to survive despite their materials, not because of them. Modern concrete was assumed to be automatically superior. Only recently did scientists decide to test that assumption. When researchers examined ancient and medieval walls in laboratories, they found clear evidence of this slow repair behavior. Under microscopes, they saw how the mortar reacted to water and air. They measured changes that modern concrete simply does not show. What they discovered forced engineers to rethink long-held beliefs. These walls were not surviving by accident. They were responding to damage in ways modern materials cannot. And once you understand this, one question becomes impossible to ignore. If medieval builders understood this system, and modern science now confirms it, then why did we stop building this way? To answer that, we first need to understand why modern concrete fails so predictably. That is where we go next. Modern concrete is strong when it is young. That is also the moment it begins to fail. This sounds strange because concrete is everywhere around us. We trust it with our homes, our roads, and our cities. It looks solid, it feels permanent. But the way modern concrete is designed makes cracking almost unavoidable. To understand why, we need to look at what modern concrete is made for. Modern concrete is engineered for speed. It must harden quickly so buildings can rise fast. Construction schedules depend on it. Projects move forward only when concrete sets in days, not months. This single requirement shapes everything about how modern concrete behaves. When concrete is poured, it begins a rapid chemical reaction. It hardens and locks into a rigid form. Once that happens, it stops changing in useful ways. It becomes stiff, dense, and unforgiving. This rigidity is often mistaken for strength. But rigidity is also a weakness. The world around a building is never stable. Temperatures rise during the day and fall at night. Seasons change. Moisture enters and leaves materials. The ground shifts slightly over time. All solid structures must deal with these forces. When a material cannot adjust, stress builds inside it. Modern concrete does not adjust well. When it is heated, it expands. When it cools, it contracts. When moisture enters, internal pressures change. Because the material is rigid, it cannot absorb these movements gently. Instead, stress concentrates in small areas. Once the stress becomes too much, the concrete cracks. This is why cracks appear even in new buildings. Sometimes they form within months, sometimes within years. The exact timing does not matter. What matters is that once a crack forms, modern concrete has no natural way to stop it. Water quickly finds these cracks. It travels deep inside the structure. In reinforced concrete, water reaches steel bars hidden inside. Steel reacts badly to moisture. It begins to rust. Rust expands, pushing outward against the concrete. This creates even more cracking, which allows even more water to enter. The damage feeds itself. At this point, the crack is no longer a surface problem. It becomes a structural issue. Repairs can slow the process, but they do not reverse it. The concrete itself cannot respond or adapt. It can only continue breaking apart under stress. This is not a design mistake, it is a design priority. Modern concrete is optimized for early strength, not long-term adaptability. Engineers know this. Builders know this. Maintenance plans are created with cracking in mind. Repairs are expected. Failure is managed, not prevented. The idea that a building material could fix itself sounds unrealistic in this context. Modern materials are not designed to interact with their environment after they set. Once the job is finished, the material is considered complete. Any future change is treated as damage. This mindset did not exist in medieval construction. Medieval builders did not aim for instant strength. They aimed for survival across generations. Their materials were chosen not just for how they behaved on day one, but for how they behaved over decades. Modern concrete behaves like glass under stress. It holds firm until it suddenly breaks. Medieval building systems behaved more like wood. They could bend slightly, they could respond, they could absorb small changes without permanent damage. This difference explains why modern buildings often need constant maintenance, while many medieval structures stand quietly without intervention. It is not because medieval builders were lucky, it is because modern concrete was never meant to heal. When a crack forms in modern concrete, nothing inside the material tries to close it. There is no slow reaction, no gradual correction. The material simply accepts the damage and continues to weaken. Understanding this failure is essential, because once you see how predictable modern concrete cracking really is, the medieval alternative no longer seems strange. It begins to look intentional. And this leads to a far more interesting question. If modern concrete fails because it is rigid and fast, what kind of system did medieval builders use instead? The answer lies inside the walls themselves. That is where we go next. Medieval walls were not solid blocks of dead material. They were built to move, breathe and survive. This single idea separates medieval construction from almost everything we build today. While modern buildings try to lock themselves in place, medieval walls accepted that the world around them would always change. To understand this system, we need to stop thinking of a wall as just stacked stones. A medieval wall was a layered structure. Large stones carried weight, smaller stones filled gaps, and between all of them was mortar that played a role far more important than simple glue. That mortar was made from lime. Lime mortar behaves very differently from modern cement. When medieval builders mixed lime with water and sand, they were not creating a material that finished its job in a few days. They were creating a material that would continue working for years. Lime mortar starts soft, it hardens slowly, and even after it hardens, it never fully stops reacting with its environment. This is the key difference that modern construction ignores. Medieval builders understood that walls would face moisture, rain would hit them, water would travel through tiny gaps. Instead of trying to block all water completely, they allowed walls to breathe. Moisture could enter, but it could also leave. This balance reduced internal stress and prevented sudden damage. When a small crack formed in a medieval wall, it did not behave the way a modern crack does. The crack did not immediately become a failure point. Water entering the crack did not always cause harm. In many cases, it activated a slow internal process inside the mortar. Lime mortar contains calcium compounds that react with air and moisture. Over time, these compounds slowly turn back into a stone-like material. This process is slow and gentle. It does not happen overnight, but over months and years, it can seal tiny cracks from the inside. This is why medieval walls often show signs of age without collapse. Small cracks appear, fade and disappear. The wall does not panic under stress. It adapts. Another important feature of medieval walls was flexibility. The mortar was intentionally weaker than the stone. This might sound backward, but it was a smart choice. When movement occurred, the mortar absorbed it first. The stone stayed intact. If something failed, it was the mortar, not the structure, and mortar could be repaired easily. Modern walls often crack through the concrete itself. Medieval walls protected their most valuable elements by allowing controlled weakness in safer areas. This made the entire system more resilient. Medieval builders did not calculate strength using modern formulas, but they observed how materials behaved over generations. They learned that walls that were too rigid failed suddenly. Walls that could adjust survived. This approach also helped medieval buildings deal with temperature changes. Stone expands and contracts with heat and cold. Lime mortar can accommodate that movement without tearing apart. Modern cement resists it until it breaks. The result was a wall that acted less like glass and more like skin. It responded to pressure. It released stress gradually. It healed small wounds before they became serious. None of this required advanced tools. It required patience. Lime mortar takes time to cure. Buildings were not rushed. Strength was measured in decades, not days. This is why many medieval structures still stand today, even after centuries of weather, movement and use. They were not designed to look perfect forever. They were designed to stay alive. For a long time, people assumed this survival was accidental. They believed medieval builders were simply lucky. But luck does not repeat itself across continents and centuries. Systems do. Only recently did modern researchers begin to treat medieval walls as engineered systems instead of historical curiosities. This discovery changed how engineers looked at ancient and medieval buildings. It showed that these walls were not frozen in time, they were dynamic. And that raises an uncomfortable truth. If medieval builders created walls that could adapt, breathe, and repair small damage over time, then their success was not accidental. It was the result of a different way of thinking about materials. But how do we know this for sure? How can we prove that this slow repair process actually happens, and that it is not just theory? To answer that, we need to step into the laboratory. That is where the story becomes impossible to ignore. For a long time, the idea that walls could repair themselves sounded like a story from the past. Something interesting but not serious. That changed when modern scientists decided to stop guessing and start testing. Instead of asking historians, they brought medieval walls into laboratories and treated them like modern engineering materials. What they found was unexpected. When researchers cut samples from ancient and medieval walls and examined them under powerful microscopes, they noticed something modern concrete does not have. Inside the old mortar were tiny particles of lime that had never fully reacted during construction. These particles were not defects, they were stored energy. In modern concrete, once the material hardens, the chemical reactions are mostly finished. The structure becomes stable, but inactive. In lime-based mortar, the story is very different. The material remains chemically alive for a very long time. Scientists discovered that when small cracks form in lime mortar and water enters, those unreacted lime particles slowly dissolve. As the water moves through the crack and reaches air, the dissolved lime begins to harden again. It turns into calcium carbonate, the same stone-like material that gives lime mortar its strength. This process does not require machines. It does not require human repair. It happens naturally, step by step, as long as moisture and air are present. The crack becomes narrower. Weak points strengthen. Over time, the damage becomes harder to detect. This is not theory. It has been observed and measured. In controlled experiments, researchers intentionally cracked samples of ancient-style lime mortar. They then exposed those samples to water and air. Weeks and months later, the cracks showed clear signs of mineral growth. The material was actively filling the damage. When the same experiments were done on modern cement, nothing happened. The cracks stayed open. No healing occurred. The difference was not small, it was fundamental. This confirmed something medieval builders may not have understood in chemical terms, but clearly understood through experience. Their walls were not passive objects, they were systems designed to interact with the environment. Scientists also noticed another important detail. Lime mortar is porous. This means it allows moisture to move through it instead of trapping it inside. Modern concrete tries to block water completely. When water finds a way in, it becomes trapped, causing internal pressure and damage. Lime mortar avoids this problem by allowing moisture to enter and exit gradually. This reduces stress inside the wall and creates the right conditions for slow repair, instead of sudden failure. Modern engineers now describe this behavior as self-healing, but the term can be misleading. The wall does not heal like a living organism. It responds chemically in a predictable way. The result, however, is similar. Small damage does not automatically turn into permanent failure. This discovery forced researchers to rethink how they judged ancient construction. Medieval builders were not working blindly. Their materials followed rules that modern science is only now fully explaining. Even more interesting is that this knowledge was not limited to one culture or location. Similar lime-based systems appear in medieval Europe, ancient Rome, and other historical building traditions. Different builders, different times, same solution. That pattern is important. It shows that this was not an accident. It was a reliable method discovered through observation and refined over generations. Modern concrete, in comparison, is chemically finished too early. Once it hardens, it cannot respond to future damage. It relies on external repairs. Maintenance replaces internal adaptability. This explains why modern infrastructure needs constant attention. While many ancient structures quietly endure, it is not because modern engineers lack intelligence. It is because modern priorities are different. Modern materials are designed for speed, efficiency, and predictability in the short term. Medieval materials were designed for uncertainty and survival in the long term. The science now makes this clear. Walls that can slowly respond to damage do not need to be perfect on day one. They need to be patient. This realization has led some modern researchers to experiment with new forms of self-healing concrete inspired by ancient methods, but recreating the full medieval system is not easy. It requires time, flexibility, and a willingness to accept slower results. And that brings us to the final and most uncomfortable question of all. If science confirms that medieval walls were built with materials that could adapt and repair small damage over time, then why did we abandon this approach? Why did speed replace patience? And what did that decision cost us? To answer that, we need to look beyond chemistry and into economics, industry, and modern priorities. That is where the real story ends. We did not stop building this way because it failed. We stopped because it took too long. This is the part of the story that has nothing to do with chemistry or stone. It has everything to do with time, money, and priorities. Medieval construction moved slowly by modern standards. Lime mortar needed weeks to set and years to fully mature. Walls were not rushed. Builders expected their work to change gradually over time. Strength was measured in generations, not deadlines. Modern construction does not work this way. Today, time is the most expensive material on any project. Buildings must rise quickly. Investors expect fast returns. Cities grow under pressure. Materials that take months to cure do not fit this system. Modern concrete solved this problem perfectly. It sets fast. It reaches high strength early. It allows construction to move at a pace medieval builders never imagined. From an economic point of view, it is a success, but that success comes with a cost. When speed becomes the main goal, long-term behavior becomes secondary. Modern concrete is strong early, but fragile over time. Its failures are predictable and accepted. Cracks are expected. Maintenance is planned. Repairs become part of the business model. Medieval builders did not think this way. They expected buildings to outlive them. Their materials were chosen not for speed, but for survival. The idea of constant repair would have made no sense to them. As industry expanded, patience disappeared from construction. Materials were judged by how quickly they performed, not by how gracefully they aged. Systems that required understanding, observation, and time were replaced by systems that promised instant results. This shift also changed how buildings were designed. Modern structures rely heavily on hidden steel for strength. When concrete cracks, that steel becomes vulnerable. Water and rust turn small cracks into serious problems. Medieval walls avoided this by keeping their systems simple and accessible. Another reason medieval methods disappeared is standardization. Modern construction depends on uniform materials that behave the same way everywhere. Lime mortar varies with climate, moisture, and local conditions. That flexibility was once a strength. In modern systems, it became an inconvenience. Industry prefers predictability. Medieval systems preferred adaptability. None of this means modern builders are careless or ignorant. They work within the rules they are given. The problem is not knowledge. The problem is priorities. Today, buildings are often treated as products, not long-term systems. They are designed to meet codes, budgets, and schedules. Durability beyond a certain point is optional. Longevity becomes a bonus, not a requirement. This is why the rediscovery of medieval wall behavior is so uncomfortable. It challenges the idea that newer is always better. It suggests that progress sometimes trades resilience for speed. Some modern researchers and engineers are now trying to bring these old ideas back. They study lime mortar. They experiment with self-healing materials. But recreating the medieval approach is difficult in a world built around fast results. Patience is hard to sell, yet the evidence remains. Medieval walls still stand. They continue to adapt quietly. They show us that materials do not need to be perfect to be durable. They need time to respond. The lesson is not that we should abandon modern concrete completely. It is that we should rethink what we value in construction. Strength alone is not enough. Speed alone is not progress. True durability comes from systems that expect change and prepare for it. The past was not primitive, it was patient, and sometimes patience builds things that last longer than progress ever does.